Let's get started. Okay, so this is the problem sheet 1. So if you have any queries, if you want me to discuss any specific problem from this, do let me know. Just type the number of the question. Just let me know if you want me to discuss any of these questions. The solutions are already provided, but in case if you want me to discuss any of the questions, do let me know in problem sheet 1. Problem sheet 1. If you want me to discuss any of the questions, please do let me know. If there is nothing, just type nothing. I would like to mention a few things. See, in this question, as we discussed in the previous class, see, in this question appeared as a calculator question, but if you pick up calculator, it is going to be disadvantageous thing for you. Okay, so do not pick up calculator for this. So that's the idea. Do not pick up calculator. And secondly, when you substitute S, first simplify the expression, then substitute. Okay, we already discussed this question in the previous class. Similar question was there in the previous class. So that is the thing you should note here. You have to first evaluate this, simplify this expression. There are two like terms. 16s minus 12s is going to be 4s. So the answer is 20. Okay. And in this question, I'll tell you a trick. Of course, you should know how to do it in the proper method, because the trick won't always work out, right? The trick is you put n is equal to 0. Put n is equal to 0. So when you put n is equal to 0, when you substitute n is equal to 0, the expression simply becomes 9 minus 7, which is 2. Right? And from the options, you can see that this is the only option which is matching, right? So have you thought about this trick? Have you thought about this method? Yeah, got it, no? So remember, this is a very easy question, but in some of the questions, you may use a trick. But you should also know the proper method, because the trick may not always work out. Yeah, in the next question, I hope you have done this word problem. Okay, the normal method is, see, Ayan has 19 more toys than his younger sister Sidra. The neighbor Sabri has 3 times as many toys as Ayan. Sidra has X toys. Which of the following expression can be used to represent the number of toys the 3 kids have in total, right? So one way to do is, see, if Sidra has X toys, Ayan has 19 plus X toys, and Sabri has 3 times as many toys as Ayan. So it is 3 times 19 plus X. And you have to add all these expressions. So it is X plus 19 plus X plus 3 into 19 plus X. So this is X plus 19 plus X plus 3 into 19 plus 3X. So we have 3X, X and X. So that is going to be 5X plus 3 into 19 plus 19 is going to be 4 into 19. 4 into 19 is 76. So it is 5X plus 76. Okay, again, the trick here is you simply put X is equal to 0. Simply substitute X is equal to 0. Simply substitute X is equal to 0. Okay, so that's the whole idea about variables. Variables can take any value. Okay. So when you put X is equal to 0, Sidra has 0 toys, Ayan has 19, and Shabri has 3 into 19. So the altogether answer is going to be 76. And the only matching answer is this. Right? Got it? So in this way, you have totally got rid of all the X terms, and it is much, much easier to crack it. Is it fine? Yeah. So in those questions with star marks, asterisks, I've mentioned in the paper that there is some trick involved. So that is why I'm discussing these questions. Again, in this question, which of the following gives the value of the perimeter of the quadrilateral when n is equal to 5? When n is equal to 5, what is the value of the perimeter of the quadrilateral? Of course, the straightforward method is you just add n minus 1, n plus 3, 2n minus 8, 3n minus 3. Okay, so you have n, 2n, 4n, 7n, 7n minus 9. Now you put n is equal to, now you substitute n is equal to 5. So it is 7 into 5 minus 9. So that is 35 minus 9. That is equal to 26. Let's see the answer. Yes, the answer is 26. The answer is 26. But what is the shorter way? What is the shorter way to do? What is the shorter way? What is the shorter way? Don't you think it's much easier if you actually evaluate the sides before simplifying the expression? So you don't have to go through the hassle of evaluating this expression. See, these are simple expressions. You can evaluate this expression at n is equal to 5. So this will be 4. This will be 8. This will be 2. This will be 12. Now you just add up all the sides. This is easier, right? Yes or no? So you should be aware of such tricks because, you know, as I mentioned in the first class, we have only about 70 to 80 seconds to crack a question on an average. So even saving 10 seconds matters. Got it? Yeah. Is this fine so far? Fine? So far it's fine, right? Yeah. In this question, problem 10, what will be the perimeter of the given triangle when each side is doubled? Okay. So you're basically doubling each side. So 2 into 2l minus 1, 2 into l plus 3, 2 into l minus 1. So this is 4l minus 2 plus 2l plus 6 plus 2l minus 1. So this is going to be 8l. Sorry, it is 2l minus 2. So this is going to be 8l plus 2. So this is a straightforward method. This is a straightforward method. Okay, but an easier way is what? Easier way is, see, instead of doubling each side and adding, it is much easier if you find the perimeter first and double that expression. What did I tell you? Instead of doubling the sides and adding together to get the new perimeter, you first find the original perimeter and then double the sides. Right? You find the original perimeter and double that perimeter, double the expression. Why? Because 2 times A plus B plus C is nothing but 2A plus 2B plus 2C. We are using the distributive property. So it's much easier if you evaluate the expression. It is much easier if you evaluate the expression, then double that expression, right? So when you evaluate the expression, you can quickly tell that it is going to be 4L plus 1, right? So the answer is going to be 2 into 4L plus 1, which is 8L plus 2. So this is slightly easier, right? This approach is slightly easier. Instead of doubling each expression and adding, I'm just adding everything first and then doubling the entire quantity. Okay, is this fine? Is this fine? Yeah, but there is another way to crack this question without actually doing it. Can somebody tell me how to do this without actually doing it? See, I just mentioned two methods. In the first method, you added all the sides, you double all the sides and then added together to get the perimeter. In the second method, you found out the perimeter first and then doubled it. But I'm telling you, there is an easier way. You don't have to actually do anything. Can somebody tell me what is the trick? Just look at the options. There is a hidden clue in the options. There is a hidden clue in the options. What is that? What is that? Please think. Any idea? Tell me yes or no. Any idea? Any idea? Any idea? You don't have to actually do this question. Just by looking at the option, you can tell what the right answer is. Anybody? Just think. Yeah, you eliminate basically, right? See, you basically eliminate. How? You know, you are doubling the expression. So it means it has to be an even number. Okay. Ultimately, for any value of L, it has to be an even number. Now, when you look at the options, this is an odd number. This is an odd number. This is an odd number. So this is the only possible answer, right? Say 8L plus 1. Irrespective of the value of L, it is going to be an odd number. 4L plus 1. Irrespective of the value of L, it is going to be an odd number. So this is odd, this is odd, this is odd, and this is the only possible even number. Is this all right? Is this all right? I want everyone to reply. Please tell me if you have any difficulties, do let me know. I mean, these are all straightforward questions, but it's about saving time in the exam, ultimately. Cool? Yeah, cool. Yeah. See, but the thing is, see, apart from knowing the shortcut, you should also know the proper method, because, you know, what if there is one more even number in the options? In that case, the trick won't work. In that case, the trick won't work. Okay. So you should always know the proper method. You should also know the shortcut method. you should also you should be knowing whether any shortcut method can be applied to that question. Okay. Again, coming to the second sheet. Again, if you have any difficulties in the beginning, do let me know. If you have any difficulties in the second sheet, if there is nothing, just let me know. Just type nothing. In the second sheet, yeah. See, basically, these are easy questions. Okay, we'll go to more difficult ones soon. But the idea is the original SAT paper do have easy questions. Okay. See, in this question, there are two approaches. One way is actually find x. Find x. Okay. And then substitute. Okay. So you have x as 6. Then you go to this expression and substitute. So we have 6 into 6 minus 18. So the answer comes out as 18. The other method is without actually finding out. Do not find x. Do not find x. Okay. Instead, rewrite the required expression as 6x minus 18 can be rewritten as 2 into 3x minus 18. Okay. So now this 3x can be replaced with 18. So the answer is 36 minus 18. Okay. See, in this specific question, there is no much difference in both methods because it's a very simple question after all. But sometimes, in some questions, this method without actually finding x and evaluating the required expression, you will be able to do it much quicker. Okay. This method will be much easier in some cases. In some cases, this method will be much easier. In this question, both methods will take up equal amount of time almost. Right? Okay. And another thing I want to discuss is this question. See, the normal way to do this is you have b is equal to 7 by 2 minus the mixed fraction 3 and 2 by 5. 3 and 2 by 5. Okay. So this is 7 by 2 minus 15 plus 2 by 5. So this is 7 by 2 minus 17 by 5. So this is 7 into 5 minus 17 into 2 divided by 10. So this is 35 minus 34 divided by 10, which is 1 by 10. 1 by 10 is nothing but 0.1. I hope you have done it in this way. Is this how you have done? Is this how you have done? But there is an easier way. Okay, there is an easier way. Okay, so sometimes it is easier if you can't think fractions as decimals. Okay, how? This 3 and 2 by 5. What is 3 and 2 by 5? What is 2 by 5 basically in the decimal form? 2 by 5 is basically in decimal form. What is 2 by 5? No, it's 2 by 5. 2 by 5, not 2 by 10. It's 0.4, right? 0.4. Right? See, 2 by 5 is nothing but 0.4. Why? 2 parts out of 5 is same as 4 parts out of 10, which is 0.4. So your expression is simply 3.4 plus b is equal to, what is 7 by 2 in decimal form? What is 7 by 2 in decimal form? 7 by 2, half of 7. Half of 7 is? Half of 7 is? Yeah, 3.5. See, in one step you are done. The answer is 3.5 minus 3.4, which is 0.1. Right? This is easier, right? Don't you think this is easier? Or is this difficult? Is converting to, yeah. Robin, see, listen. This 3 and 2 by 5 basically this is 3 plus 2 by 5. Right? And this 2 by 5 is nothing but 2 by 5 in the decimal form is nothing but 0.4. Okay, because 2 parts out of 5 is nothing but 4 parts out of 10. 4 by 10 is 0.4. Cool? Robin, is that cool? Yeah, so this is nothing but 3.4. On the RHS, we have 7 by 2. 7 by 2 is half of 7. Half of 7 is 3.5. Half of 7 is 3.5. Is that difficult to imagine? Half of 7 is 3.5. Half of 7 is 3.5. Is that all right? Yeah. So we have 3.4 plus b is equal to 3.5. So your b is nothing but 3.5 minus 3.4, which is 0.1. Cool. Is that okay? So in the last 2 problem sheets, if you have any further difficulty, do let me know. If there is nothing, we'll move on to the next topic. If there is nothing else to discuss, we'll move on to the next topic. Shall I move on to the next topic? Or if you have any difficulties, do let me know. See, please listen. See, the whole idea about cracking SAT math is doing a lot of problems, okay? When you look at each questions individually, these are very easy questions. But within the time limit, you should be able to do about 58 questions. Okay, so you should be able to do them very quickly. So thing is, you should have a lot of practice. You should know shortcut methods. You should know tricks. You should know alternate solutions. You should know a lot of strategies like substituting, eliminating the options, and a lot of other things, which we'll see in due course of the our classes. All right. Yes. So this is not time consuming, right? We'll go ahead with this problem sheet model. After every class, I'll be giving you a problem sheet. This won't take much time, right? You're fine with it, right? Yeah, cool. So let's go to the next topic. So in the next topic, we are talking about multi-step equations. Multi-step equations. I mean, those equations which will take more than one step to solve. So earlier, the questions could be solved in just one step, as in either addition, subtraction, or you had multiplication, division. We already saw all this type of questions. Yeah. Now let's look at the question which will have both operations involved. Okay. So for example, I'll give you a quick question. 3x plus 7 is equal to minus 5. Can you try it first? Can you try it first? 3x plus 7 is equal to minus 5. If you have the answer, do let me know. Yeah, Prisha has already given me the answer. Anjali has the answer. Olivia has the answer. See, the whole idea is we have to isolate the variable. Okay. So you have to keep undoing the operations one by one. You have to keep undoing the operations one by one. First of all, you have to undo that 7. Okay. So we have 3x is equal to minus 5 minus 7, which is minus 12. Now we have to undo the 3. Okay. So you have to divide by 3. So x is equal to minus 12 divided by 3. So it is minus 4. Now, one thing I want to reiterate is it is always better to check your answer by substituting it back in the original question. Okay. Always check your answer by substituting the answer in the original question. Please substitute the answer in the original question and do let me know whether it satisfies. Please do that. Yeah, it satisfies, right? It satisfies. Okay, cool. Let's quickly do a real before that, let's see a similar type of question which involve fractions. Questions involving fractions. For example, q divided by 15 minus 1 by 5 is equal to 3 by 5. Can you try this first? If you have the answer, do let me know. Yeah, Olivia has the answer. What about others? What about others? No, you are finding the unknown quantity here. Q is the unknown quantity. Q. It's not 9. It's Q. You're solving for an unknown quantity here. This is again a linear equation in one variable. Just that instead of normal integers, we have fractions. That's all. So fractions and decimals are these SAT's favorite stuff. Okay, they do ask a lot of questions on fractions and decimals. What about others? Olivia has the answer. What about others? Yeah. Prisha has given me the answer. Cool. See, children, listen. These are actually easy questions. Okay. It's about cracking them fast and accurately. Okay, fast because we have a time constraint. Accurately because even if you make a small mistake, it is possible that your wrong answer would show up in the options. Okay, you have to do it accurately because suppose you make a mistake and the options would be given in such a way that your wrong answer would have come up in the answers, in the options. Okay, that is how they set the options. Yeah. Now please listen, everyone, please listen. See, there are two ways to crack this, two ways to solve it. One way is doing fraction operations. One way is by doing fraction operations. Right? So Q by 15 is equal to 3 by 5 plus 1 by 5, which is nothing but 4 by 5. Now Q becomes what? 15 into 4 divided by 5. These 5 and 15 gets cancelled off. We have 3 as a quotient. So the answer is 12. This is one way to do it. So one way is fraction operations. Okay. Is this how you have done? Hello. Is this how you have done? By doing fraction operation? And second way is getting rid of fractions. Get rid of fractions. How will you get rid of fractions? We have q by 15 minus 1 divided by 5 is equal to 3 divided by 5. So the idea is you have to multiply the entire expression, both LHS and RHS, by LCM, the least common multiple of the denominators. The least common multiple of the denominators. So the denominator you have 15 and 5. 15 and 5. The least common multiple is 15. For 15 and 5, the least common multiple is 15, right? For denominators, the least common multiple is 15. So you multiply the entire expression with 15. See, listen carefully. You multiply the entire expression by 15. Is this step okay? Is this okay for you? If there is any confusion, do let me know. Do not hesitate. Robin, Anjali, Olivia, Prisha. See, you have to look at the denominators. The denominators are 15 and 5. 15 and 5. Of course, there are two 5s appearing, but the distinct denominators we have are 15 and 5. Now we have to find the LCM of least common multiple of 15 and 5. I guess you have learned the term as least common denominator. Maybe you have learned it as least common denominator. But the common usage is least common multiple of two numbers. Least common multiple of two numbers. So 15 and 5. What are multiples of 15? Multiples of 15 will be of the form 15, 30, 45, 60, etc. Right? What are multiples of 5? Multiples of 5 will be 5, 10, 15, 20, 25, 30. Now we are looking at the common multiples of both the numbers. Common multiples will be 15, then there is 30. Okay. Then you have to pick the least common multiple, which is nothing but 15. Is this okay? How to pick LCM of two numbers? How to choose LCM of two numbers? How to choose the least common multiple of two numbers? Now, when you have figured out what the LCM is, you multiply both the expression by the LCM. Multiply both the expression by LCM, which is nothing but 15. Now what happens? This 15 will help you to get rid of the fractions. Why? Because in the LHS, we have 15 into cube by 15. We have 15 divided by 5 is equal to 3 into 15 divided by 5. Right? So 15 by 15 is 1. 15 by 5 is 3. And here it is again 3. So we have q minus 3 is equal to 3 into 3 is 9. So you have an expression sans fractions. You have an expression without any fractions at all. Right? Yes. Now the answer will be 12. So you understand the logic, right? When you multiply with the LCM, this LCM will be a multiple of 15 and multiple of 5. So you can easily cancel off. Okay, you can easily cancel off the terms and get a good looking expression. Right? This is okay. Of course, you could have chosen 30. There's no issues with choosing 30. Okay. See, what if I had multiplied with 30? See, q by 15 minus 1 by 5 is equal to 3 by 5. Now, what if I had chosen 30 instead of 15? Suppose if I had chosen 30. 30 is a common multiple, but it is not the least common multiple. 30 is a common multiple, but it's not the least common multiple, right? So if I had multiplied with 30, then also you would have got the answer, right? So we have 30q minus 30 divided by 5 is equal to 3 into 30 divided by 5. So 30 and 15, we have 2 here. 30 by 5 is 6. 30 divided by 5 is 6. So you have 2q minus 6 is equal to 18. All right. This is all right. So if we had chosen any other common multiple, then also we could have got rid of the fractions, right? So that is the idea of common multiple. Okay, that is the idea of common multiple. Of course, it makes much more sense to multiply it with the least common multiple, because you have a simpler expression in this case. Okay, you have a simpler expression when you multiply it with the LCM, right? So it makes much more sense to multiply with the least common multiple and not any common multiple, right? Got it? So ideas what? You have to choose a common multiple, and if you choose that common multiple as the least common multiple, the math would be much easier. So far, so good. So again, if you solve it, you're going to get the same answer, because 2q will be 24 and your q will be 12. So far, so good. Yeah. Robin, if you're stuck, do let me know. Yeah, you figured out this thing. This is fine with you. The first part is okay for you. In the first part, I have chosen the least common multiple. Is that okay, or it's still confusing? Is the first part confusing? Yeah, it's still confusing for him anyway. Okay, it's okay. See, I'll just explain once again. We have q divided by 15 minus 1 by 5 is equal to 3 by 5. Okay, so here in this question, what is given as differently? What is given differently? All the numbers are fractions. Okay. So earlier question you had integers. Here we have fractions. So you simply have to do fraction operations. Okay, that is one way to do it. So we have q by 15 is equal to 3 by 5 plus 1 by 5, which was 4 by 5. And q by 15 is equal to 4 by 5. So your Q will come out as 15 into 4 by 5. So that will be 12. That is one way to do it. Okay. Yeah. And other method, what I'm talking about is, this is fraction operation. Okay. If you're still stuck with the fraction operation, please do revisit it. Okay. From your lower classes. Please do revisit the fraction operations from your lower classes, because it's absolutely important that you know how to manipulate fractions. Yeah. The second method I'm talking about is getting rid of fractions. And for that, you have to look at the denominators. You have to look at the denominators and you have to look at the least common multiple of the denominators. And the denominators are nothing but 15 and 5. Okay, now you write multiples of 15. Multiples of 15 are 1 times 15 is 15, 2 times 15 is 30, 3 times 15 is 45, 4 times 15 is 60, and so on. Multiples of 5 are 5, 10, 15, 20, 25, 30, and so on. Now, you choose common multiple. And in fact, you choose the least common multiple. You multiply the entire expression with the least common multiple. Now you can distribute. So this is 15 into Q divided by 15 minus 15 by 5 is equal to 3 into 15 divided by 5. Yes. So 15 and 15 gets cancelled off. 15 by 5 gives you 3. 15 by 5 gives you 3. So you have Q minus 3 is equal to 9. So you have Q is equal to 12. I hope it's fine now. Robin. See, if you're still finding it difficult, it means you are struggling with the fraction operations and the idea of manipulating fractions. So please do revisit it, because we will need it often. Please do revisit it. And I told you one more thing. Instead of choosing 15, you could have chosen 30 as well. You could have chosen any common multiple. Okay, you could have chosen 30 as well. If you had chosen 30 as well, you would have got the same answer finally. But it makes a lot more sense to choose the least common multiple, right? Right. See, in math, everything is logical. You don't have to mug up stuff. You don't have to blindly mug up stuff. Everything what we do makes sense. Right. Am I right? Am I right? Choosing the LCM makes sense, right? Choosing the least common multiple makes sense. Now, if we had chosen a number which was not a common multiple, what would have happened? If I had chosen, say, a number, say 10, which is not a common multiple. Say if I choose to multiply the entire expression with 10, what would have happened? So you have 10 times Q by 15 minus 1 by 5 is equal to 3 by 5 into 10. Now what happens? See for yourself what happens. We have distribute the 10. We have 10 into Q divided by 15 minus 10 divided by 5 minus 3 into 10 divided by 5. See, in 10 and 15, you can cancel off 5. We have 3 here. We have 2 here. Here, it is 2. Here in 10 and 5, it is 2. So you have 2q by 3 minus 2 is equal to 6. See, the fraction is still there. The fraction is still there. In some places, the fraction is still there, right? Now it makes sense why we choose a common multiple, and more specifically, why we choose the least common multiple. Is that all right? Okay. So we are basically discussing multi-step equations. Okay. We are done with single-step equations in the previous class. We are discussing multi-step equations. So we saw the normal example. We saw the equation having fractions. Let's see one question which involves decimals. Let's see one question which involves decimals. See, 3x plus 0.9 is equal to 2.7. Please try it first. Everybody is getting different answer. Yeah. Prisha, please check your answer again. So what is the idea? We have 3x is equal to 2.7 minus 0.9. So 2.7 by 0.9 is basically 1.8. So we have x is equal to 1.8 divided by 3, which is going to be 0.6. Cool? That's cool, right? Yeah, okay, no problem. Next type is equations having like terms. Equations having like terms. So like terms, say for example, say you have 5.20n plus 0.80n plus 47 is equal to 377. So you have like terms here. What do we do? What do we do? Yeah, combine the like terms. Combine the like terms. Combine the like terms. Yeah, please combine the like terms and tell me what the answer is. Oh, that's very cool, Anjali. Prisha, I think you have made some mistake. Please check your answer. See, it's not only about doing it quickly, it's also about doing it accurately, okay? Because, you know, most of the questions, if you make the silliest of the mistake, the wrong answer you got now, that would have appeared in the options. Okay, they would have created the wrong options in such a way that even if you make the silliest of the mistake, that would have shown up in the options. So we have 5.2 plus 0.8. So we have 5.20 plus 0.80 times n is equal to 377 minus 47. And this is nothing but 330. It's not 337. Prisha. Yeah, cool. So we have 6n is equal to 330. 6n is equal to 330. So your n is 330 divided by 6. It's okay. And by the way, suppose this is a non-calculator question, you should be able to solve this without actually picking up your calculator. And I've already mentioned that in most of the, I thought you could only combine the terms that are on the same set. Of course, see, maybe I've skipped a step. See, listen. You can combine these two terms. Okay, combine these two terms. It is 5.20n plus 0.80n. This will become 5.20 plus 0.80 times n. Right? And what about 47? What about 47? You add minus 47 on both sides. Right? Robin, that's what I'm doing. You add minus 47 on both sides. So it's basically combining. You can combine expressions on both sides. Okay, you can combine expressions on both sides. The only thing is 47, when it goes to the other side, it becomes minus 47. That's all. So this becomes 377 minus 47. That's the whole idea. So you have 6n is equal to 330. And remember, you should be able to do this without using the calculator, because even if it's from the calculator part, picking up calculator and plugging in the numbers and getting the answer is going to be a waste of time. You don't have that kind of a time, right? Even if the question appears in the calculator part, picking up the calculator, plugging in the numbers, finding the answer. But you should be able to much quicker by using pen and paper, right? So we have 5, 30, that is again 5. It is 55. Cool. Can I take 2 more minutes? Can I take two more minutes before we wind up? Yeah. So let's do actual SAT questions. Yeah. An actual SAT questions. Let's do this question. Prisha, please be careful. We can't afford to make silly mistakes here. We can't afford to make silly mistakes here. Yeah, that's right. Okay, that's cool. 3x is equal to 1.8 plus 0.6, which is 2.4. So your x becomes 2.4 divided by 3. It becomes 0.8. Cool. Okay, we have one more question. I think I'll give you this in the problem sheet. Okay, no issues. So I'll share a problem sheet with you. Okay, please do work out these questions. It won't take much time. See, how much time did it take the previous sheets? It took only a few minutes, right? Right. Yeah. So I'll keep sharing the problem sheets because we need a lot of practice. Okay, keep the sheets with you. Keep practicing it often, because you should not remember these concepts. Remember the tricks. I've shared a few tricks. See, I've not included those tricks in the solution. Just like substituting, eliminating the options, those tricks. So go back to your sheet and make a note of those tricks in your sheet itself. Okay. So I have not shared those tricks in the sheet. So after discussing those tricks, you go back to the sheet and make a note of those tricks in the sheet itself. Okay, we'll meet again in the next class.